Welcome to this video on the awesome range of acid strength. It's an opportunity to pause and to marvel and to wonder at the amazing universe we live in. So get your jaws loose, make sure you've got plenty of space to let them hang as we consider the awesome range of acid strength. The acid strength varies a lot. Here's the strongest acid we think we know about at the moment, carburetor acid with 11 fluorines on. That's predicted to have a pKa of -46. all the way down through the strong acids like HCl, the weak acids like ethanoic acid, all the way past water to the non-acids, things like methane with a pKa of 48, and that's not as high as it can go. So acid strength varies by nearly 100 orders of magnitude. Just to give you an idea about how weak and how strong these acid molecules are, I'm going to talk you through some illustrations. The methane is so weak that if you consider placing a mole of methane into a bottle of water with a volume of 1 decimeter cubed, or a 1 litre bottle of water, at that concentration the fraction of molecules of methane that is dissociated is 1 in every 10 to the 27. That's 1 with 27 zeros after it. That's the fraction of molecules dissociated. So you need 10 to the 27 molecules in order to statistically have one methane molecule that has split up into a CH3- ion and an H3O+ ion. Now, in order to do that, you're going to need a lot of water. You're going to need more than just 1 litre of water, because 1 litre of water only contains this many methane molecules. In fact, you need about 1.66 cubic meters of water. Well, how big is that? You could think of it as being a cube about 1.2 meters in size, or you can think about it as being 2 full bathtubs, like these. What about carburetor acid? Carburetor acid is so strong, it's on the opposite end of the spectrum, that it so readily loses this proton here to become this anion and H3O+, that if you take a mole of carburetor acid molecules and put them into a decimeter cubed of water, that would leave you with only 1 out of 10 to the 46 which are not dissociated or undissociated molecules. That is a tiny, tiny number. In 1 mole, you've got a huge number of molecules, but this is like saying you need a mole of moles almost. And in fact, you need 1.66 times 10 to the 19 cubic meters of water. Well, what objects have that scale? Well, one very, very large body of water that we know about is the Earth's oceans. It turns out the Earth's oceans are much, much smaller than that volume. In fact, you wouldn't just need 1 Earth's oceans in order to be able to find enough water to find just 1 undissociated carburetor acid molecule, or 2, or 3, or 4, 5, 6, 7, 8, 9, 10, no, still not enough, 11, 12, 12 and a half. 12 and a half times the Earth's oceans in volume is needed to just find statistically 1 undissociated carburetor acid molecule. That is a strong acid. The universe we live in is amazing.